This is the FEMA Substantial Damage Estimator Training Series. Welcome to Module 5, Residential and Non-Residential SDE. In the first part of this module, we'll be discussing how to carry out an assessment on residential structures. We'll cover non-residential structures in the next part of this module. We have several topics to cover. We'll look at the types of structures that fall under the residential category, attributes of those structures, how to evaluate the quality of the structure, making cost adjustments, the use of element percentages to calculate damages, and determining damage to each element of the structure. One thing to keep in mind is that it is important to take high-quality photos anytime you are performing an assessment. These photos will help illustrate the structure's attributes and damage to anyone who views the assessment after you have completed it. So it is critical to ensure that your photos are clear and really capture all the key components of the structure. Residential structures can generally be broken down into just 3 different types: single-family residences, town or row houses, and manufactured homes. Although there are other types that may be selected when performing assessments, these 3 are the most common and cover a majority of the structures that will be evaluated in the field in the United States. One common misconception related to these structure types is modular or prefabricated homes that have been built off-site and are then trucked in and placed on a site. Since they are built off-site, it is easy to confuse these as manufactured homes. But these types of structures should be considered single-family residences since their design is closer in type to single-family construction. One easy way to distinguish between a manufactured home and a modular home is to look at the framing. A manufactured home will generally have a metal frame, while a modular home will typically have a wood frame. It is also very important to note that while apartment buildings do house residents, they are owned as businesses and therefore considered non-residential structures. Another important part of carrying out the SDE assessment is determining the structure's attributes, the first of which is foundation. Here you can see examples of the different foundation types. These can be used as a reference to help determine the foundation type of the structure being assessed when you are in the field performing assessments. The most common type of foundation will vary regionally. A couple of important distinctions arise when evaluating foundation types. Although the piles foundation type can often appear similar to piers and posts, it is distinct in that it is generally only found in coastal areas where the supports are driven into the ground and embedded several feet below grade. A basement foundation type is one where all sides of the foundation are enclosed and the foundation is wholly below grade. This is distinct from a crawlspace or continuous wall with slab because neither of these foundation types are below grade. This definition of a basement is much broader than that used by the NFIP, in which a basement refers to any area whose floor is below grade on all sides. The next structure attribute we'll cover is superstructure. In layman's terms, the superstructure refers to the bones of the structure and is the primary part of what is keeping the structure standing. The superstructure does not refer simply to the exterior finish on the outside of the house, which may be made of a different type of material than the superstructure. In SDE, there are 4 types of superstructure: stud-framed, masonry, insulated concrete forms, and common brick. Here we can see examples of each of the different superstructure types and note some important differences between those types. A stud-frame structure uses wooden studs as the primary support system, and exterior siding is generally applied as the covering on the outside. Masonry construction uses concrete masonry units, or CMUs, that are stacked and mortared together, while ICF uses a synthetic forming system that is filled with concrete to provide structural support. One of the most common errors when carrying out assessments is to identify bricks on the exterior of the structure and assume that the superstructure type is common brick. A common brick superstructure requires the brick to be a part of the support system for the structure. Home builders may use a brick veneer on the outside of a structure, which is an exterior finish that does not provide any structural support, and is often added to provide a different aesthetic to the home. There are also 4 types of exterior finish that can be selected in SDE, and the most common types are generally the first 2 listed: siding or stucco and brick veneer. A siding or stucco finish is relatively common in the United States and generally refers to a vinyl, aluminum, wood, or stucco finish. Siding is often marked by the overlaying of strips of waterproof material that are connected to wall sheathing or other materials. EIFS is a type of synthetic material that can also be attached to the exterior sheathing of a stud-framed house and generally consists of a rigid insulation that is covered over with stucco-style finish. If there is no exterior finish and the superstructure is the top layer of exposed superficial material, the option of none can be selected in SDE. Roof covering is another important attribute of a residential structure and is also classified in 4 types. Shingles are the most common roof type by far and are composed of overlapping layers of covering. Clay tiles are often distinguished by their red color and semicircular form. They are placed in parallel rows that overlap to prevent water intrusion. A slate roof is much less common due to the high cost of installation, but are hardier than other roof types and have long lifespans. Similarly, standing seam roofs have long lifespans and are made of metal panels that are crimped together. Standing seam roofs should not be confused with common sheet metal roof covering, which is not composed of interconnected crimped panels. Instead, these roofs are often made of corrugated sheet metal that has simply been laid down on top of the roof superstructure and nailed down or otherwise connected. For these types of roofs, standing seam should not be selected because the cost and style of these roofs is more akin to a shingle roof. Another structural attribute that can be selected within SDE concerns whether the structure has a heating, ventilation, and air conditioning system, or HVAC. Although this is a simple yes or no selection, there are a few important points to remember. An HVAC system in SDE is considered a built-in central heating and cooling system. Often, a true HVAC system can be identified from the outside by a compressor unit that circulates the refrigerant in the system. That means that portable window air conditioning units or other types of removable heating or cooling units would not be considered an HVAC. If these are the only types of heating or cooling systems in the household, you should select none for HVAC. The next attribute to identify is the number of stories that a structure has. Here you can select either 1 story or 2 or more stories. Structures that only have a partial second story should be included in the 2 or more stories category. When determining structure quality, it is important to remember that the quality of construction refers to the quality when the home was initially constructed. It does not refer to the current quality level of the home, which may have been impacted by poor maintenance by the homeowner. In any given neighborhood, there likely will not be a wide range of quality types. That is to say, it would be unlikely that a home of excellent quality would be found in the same neighborhood as a home with low quality. This scale lays out some of the attributes of each residential structure quality type, and you can see that as we move from low to excellent quality, there are changes in the amount of ornamentation and complexity of the construction. In short, lower quality level structures tend to be plain and constructed on a mass production scale, whereas higher quality levels tend to have more design features and are often custom built. Now we will move into the portion of the assessment where we evaluate the actual damage to the home. But before we begin, you must remember that there is a difference between the damage that has been done to a structure and deferred maintenance. Think about what repairs would be needed to bring the home back to its pre-damage condition. For example, paint that is peeling off of the exterior or windows that have not been replaced for many years and are simply old would not count towards the damage estimate. Cost adjustments for the different structural elements can also be made to account for homes that may have a higher quality related to any of the features listed. There should be a clear reasoning for making these adjustments, and this should only be done when there is a discernible difference in the feature. To carry out a residential damage assessment, an assessor will evaluate 12 different elements of the home and determine the percent damage of each. Try not to overcomplicate the assessment. Since you are working in percentages, if 50% of the roof has been torn off the home, then the damage to the roof element should be 50%. Also, when working in an area, it is critical to coordinate with assessors and your SDE team lead to ensure that assessments of damage are consistent across all team members working in the field. Many of the features we'll be evaluating are related to the structural attributes we identified in the first part of the assessment, which is why it is so important to correctly identify those attributes. Data about each of the 12 elements can be recorded in the SDE tool. The assessor records the percent damage for each element, and the SDE tool then calculates the damage value automatically using the overall element costs. This is based on the structural attributes the assessor put into the tool in the first part of the assessment. You can also see that the assessor used multiples of 5 when putting in damage percentages for each element. Evaluating and recording the damage percentages is the most critical part of the assessment, as it is the basis for determining whether a structure has been substantially damaged. The damage percentages are the key piece of data that you as the assessor input to calculate the ultimate dollar damage to the structure. Most of the other information that goes into the calculation is either built in or derived from building attribute data. When carrying out an assessment, remember to keep an eye out for the many types of damage that may impact a structure. Some types of damage, such as a roof that has been torn off of a structure, may be obvious, while others, such as misalignment of a foundation, may not be immediately evident until you perform a more in-depth evaluation. When determining element percentages, think about what kinds of repairs and replacements might need to take place to return the home to pre-storm conditions. When you do this, distinguish between damage to the structure and poor maintenance, the latter of which should not be included as part of your damage assessment. Now we'll spend some time going through element by element to discuss some of the common damages to look out for when evaluating each feature of the structure. First, we'll look at foundations. For any foundation type, check for cracks and obvious physical damage to the structure of the foundation itself, and if there is any misalignment between the foundation and the rest of the structure. This may indicate that the structure is no longer stable. You may note damage to utility lines that have been broken because the structure has been moved. For structures on piles or columns, evaluate the piles for damage and ensure they are still connected to the structure. Also examine the base of the piles for scour that may indicate that the piles have moved and may not be structurally sound. Slab-on-grade structures should generally be evaluated similarly to continuous wall slab, as you should look for cracks in the slab, subfloor upheaval, or misalignment between the foundation and structure. When evaluating homes with a basement foundation, view the entire basement as part of the foundation system. While cracks in the wall may be obvious signs of damage, you should also be on the lookout for cracks in the floor or misalignment between the basement walls and the rest of the structure. Next, we'll look at how to evaluate the damage to the superstructure of a home. When looking at a common stud frame structure, one of the first evaluation points should be to determine if there is damage to the studs. Remember that the superstructure only refers to the bones of the structure, and not to elements like drywall or insulation, which do not support the stability of the structure. For masonry construction, look for damage to the joints where mortar is used to connect the CMUs, as these are potential weak points where failure is most likely. Similar to evaluating foundations, inspect the superstructure of a masonry home for misalignment in the CMUs or places where it appears there may be loose or missing blocks. The next element we'll assess is the exterior finish. This is a non-structural element of the home and refers to damage to siding or other exterior covering. For all of the exterior finish types, you will essentially be evaluating the structure for the same kinds of damage. Frequently, there is clear damage to the exterior finish when wind events impact a home and tear off siding. Inspect the exterior finish for damage that may not be immediately apparent, such as when floodwaters seep up behind the surface of the exterior finish and cause damage that may require the finish to be replaced. Be aware of any cracking or loss of attachment between the finish and the underlying sheathing that would be grounds for repairing or replacing parts of the finish. In SDE, roof damage only refers to roof coverings and sheathings, not the structural components of the roof, which would fall under damage to the superstructure. When evaluating the roof of a structure, you should look for holes in the roof covering, missing shingles, and seepage under the roof that appears to have damaged the underlying sheathing. The interior finish includes many of the fixed features that are non-structural members of the home, such as interior walls, paneling, trim, baseboard, railings, molding, and other ornamentation that is permanently attached to the home. Interior finish does not include elements such as doors, windows, flooring, plumbing, electrical, appliances, or HVAC, which are all covered under other element damage categories. Additionally, SDE does not evaluate damage to items like furniture, electronics, photos, or anything that is not considered a permanent feature of the structure. You may commonly run into damage where there is a need to repair or replace sections of drywall. This is especially true when floodwaters have caused damage above the first floor of the structure. Often, drywall can be cut and replaced in sections, so it is important to remember that just because there is some damage to a wall, the entire wall of drywall may not necessarily need to be replaced. Be aware of less apparent damage, such as when trim, baseboard, or other features may have been warped or split and require replacement. The next damage element that is evaluated is the doors and windows category. This includes all exterior and interior doors and windows, which should be evaluated for breakage, warping, and damage to weather seals. If any hardware or seals need to be replaced, these will count towards the element's damage percentage. In flood events, doors and windows are also often a good place to begin your search for a high water mark, as sediment tends to get trapped in the corners and crevices of these elements of the structure. Cabinets and countertops are covered in the next element category and includes cabinets and counters in the kitchen, bathrooms, laundry, and any other areas of the home which may contain these features. You should only evaluate permanent features of the home, so removable storage cabinets, bookshelves, and features that would not normally be transferred as part of the sale of the house should not be evaluated for damage. As with many features on the interior of a home, cabinets and countertops should be evaluated for warping, splitting, and damaged hardware, among other types of damage. For flood events, it is also important to remember that especially in kitchens, there is often a set of upper cabinets and a set of lower cabinets. While lower cabinets may have been excessively damaged due to rising floodwaters, upper-level cabinets may have received little or no damage, and your damage percentage should reflect this. Floor finish refers to the interior surface of the floor covering and can come in many different types, including wood, laminate, tile, vinyl, composite, and carpet. As with other elements, you will need to inspect the flooring for cracks, warping, and splitting. In flood events where the depth of flooding is above the first floor, it is common for the entire floor finish to be replaced, especially when the finish is wood, laminate, or carpet. In these cases, you would likely determine that the damage percentage is 100%. Plumbing includes all fresh and sanitary water conveyance lines, as well as a number of permanent features of the home that use water, such as toilets, sinks, bathtubs, and showers. Damage to water lines can often be identified if there are apparent leaks or disconnected pipes that may indicate that there is an issue. Check locations where there are valves and connections that may have been damaged. In many cases, you should also consider that water lines may only require cleaning or disinfection, not full-scale replacement. If this is the case, the damage percentage for this element will likely be far lower than if parts have to be replaced. Electrical damage includes any of the wiring, outlets, switches, and junction boxes that provide power to the home. After flood events, these electrical features should be evaluated for damage due to corrosion. Flood events can be particularly damaging to electrical systems as these elements usually cannot function after they have been wet. When evaluating appliances, evaluate only the built-in appliances. As mentioned previously, SDE is focused on the permanent features of the home, which can generally be classified as those that will be transferred along with the sale of the home. Ovens and dishwashers are appliances whose damage would be included in an SDE assessment, while countertop microwaves or crockpots are considered personal belongings and would not be included. When evaluating damage, consider broken glass and other features along with the functionality of the appliance. The final damage element is the HVAC system. As noted previously, only built-in HVAC units are evaluated for damage. Window units or other portable heating or cooling units should not be counted in the damage assessment. For built-in units, be sure to consider the entire HVAC system and not just the compressor unit that may need to be replaced. In many cases, while the compressor is damaged and needs to be replaced, other features of the HVAC system may be in good working condition, and the damage percentage should be adjusted accordingly. Non-residential structures are evaluated somewhat differently than residential structures. However, the basic process of collecting information and assessing damage remains the same. We will cover a number of different topics concerning how to assess non-residential structures, including the collection of structure information and attributes, determining the structure type, and assessing damage. When carrying out a non-residential structure assessment, the first step is to ensure you have selected the non-residential structure type under the Structure, Damage, and FIP Information tab. Because of differences in construction materials and style, choosing non-residential under the structure type will change the options for information that the tool asks you to put in the assessment. Make this change before beginning any non-residential assessment. Although selecting non-residential is important, it is not the main factor in determining the value of the structure. The number of stories and building use are the critical factors that SDE needs to make this determination. Once you have selected non-residential as structure type, you will be given a number of different choices for both number of stories and structure use. The choices for structure use will vary based on the number of stories you have selected. In some cases, you may find that there is not a structure use option that matches exactly to the structure you are assessing. In these cases, you should select the structure use that is most akin to the structure you are assessing and record a note in your assessment to ensure that the information you collected is well documented. When performing a non-residential assessment, there is less information that you need to provide to complete the assessment in terms of the structure information. In addition to the number of stories and structure use, you may also be asked if there is a sprinkler system installed in the structure or if there is a conveyance system. A conveyance system refers to whether the structure has an elevator or escalator, and so the option to select this for a one-story structure will not be available since there is no need for an elevator in a one-story structure. Similarly, for structures of 5 stories or more, the option to select sprinkler systems and conveyance systems are not available, as it is assumed that these structures will have both of these systems in place. Selecting construction quality should be carried out in the same manner as for residential structures, and the same options are available. When you select the number of stories for the structure, you will be given a different set of options for the structure use when you select 1 story versus when you select 2 to 4 stories versus when you select 5 or more stories. In some cases, you may find that the best structure use type is not available when you select the correct number of stories for the structure, but that it is available when you select the incorrect number of stories. For example, you may be assigned to assess a 2-story elementary school, only to find that elementary school is not an available choice for structure use when a two-story structure has been selected. You would also note that elementary school is an option under structure use if a one-story structure is selected. In this case, you would select one story as the number of stories so that you could choose the appropriate structure use, even though the number of stories you selected is actually not accurate. That is to say, trying to choose the most appropriate structure use should take precedence over trying to choose the correct number of stories when completing a non-residential assessment. This is because construction type is not the primary factor in determining the element breakdown. Structure use is the main factor that determines this, so it is most important that this attribute is accurately selected. Here you can see all of the different structure uses that can be selected for a one-story structure use. For 2 to 4 stories and 5 or more stories, there are far fewer options, and several are the same as those listed under the one-story option. As with residential structures, you will also need to select the quality of the structure. As a reminder, the quality should reflect the original construction quality of the building and should not factor in poor maintenance that may impact the current condition of the structure. Also similar to residential structures, cost adjustments for the different elements can be made to account for enhancements or features that the structure may have that impact its quality. However, it should be noted again that there should be a clear reasoning for making these adjustments, and this should only be done when there is a discernible difference in the feature. There are only 7 damage percentages that must be evaluated for non-residential structures: foundation, superstructure, roof covering, plumbing, electrical, interiors, and HVAC. You may note that, among others, elements such as cabinets and countertops, flooring, and appliances are all not included in a non-residential assessment. Here you can see what the element percentages tab for a non-residential structure looks like. The 7 different elements have not been evaluated, but this demonstrates that putting in the percent damages is the key to carrying out the assessment, and that the damage values will calculate automatically within the tool once the damage percentages are entered. Many of the elements that you will evaluate in a non-residential assessment are the same or similar to those you would evaluate in a residential assessment. Your approach to evaluating these elements will also be similar. For foundations, you will again focus on looking for cracks, misalignment between the foundation and structure, scour around the base of the foundation, and general instability. When you evaluate the superstructure, focus on the structural components of the building, such as the studs or the CMUs that support the building. Inspect the superstructure for cracks and other damage that may have caused instability in the structure, and be aware that some damage may not be immediately apparent on the surface. Roofing will also be assessed when looking at a non-residential building and should be evaluated similarly to a residential structure, with a focus on holes in the roof covering, lost shingles, and seepage under the covering that may cause damage to underlying sheathing. Some non-residential structures may have more extensive plumbing systems in place, depending on their use, but the evaluation of the plumbing element should remain the same as for residential structures. Assess that water lines are intact, and be sure to differentiate between lines that may just need to be disinfected and those that actually need to be repaired or replaced. Electrical systems in some non-residential buildings may also be more extensive or elaborate than in residential buildings, again depending on their use. But these should be evaluated in a similar way. Inspect for corrosion and water damage to wiring in the structure, and evaluate junction boxes and other major electrical features that may have been damaged. Interior damage in a non-residential structure incorporates several of the elements of a residential assessment. You may include damage to floors or other permanent features of the structure in this assessment. Features such as machinery or equipment that is considered part of the structure of the building would often count as part of the interiors. As with residential structures, the key is to think about what is essentially a permanent part of the structure itself. A stove at a fast food restaurant would be considered part of the interior of the structure and would be included in the damage assessment. However, a countertop microwave in the break room of an office building should not be assessed for damage. HVAC units for non-residential structures may be large, and it tends to be less common to see a non-residential structure that does not have a central HVAC unit. That said, the evaluation of non-residential HVAC units is the same and involves determining if the unit is functioning and whether or not there is damage to the unit overall. This concludes our module on residential and non-residential structures. For further information on evaluating structures using SDE, refer to the FEMA SDE User Manual and Field Workbook. Thanks for watching. This training is one of a 10-part series. Please continue to Module 6.